Karpathy just open-sourced a repo that lets AI agents do machine learning research while you sleep. So here's the setup. Karpathy, the guy who built Tesla's self-driving neural nets and co-founded OpenAI, dropped a repo called autoresearch about 5 weeks ago. The idea is dead simple. You point an AI coding agent at a single training script, tell it to experiment, and then you go to bed. The agent modifies the code, runs a 5-minute training loop, checks if the model got better, keeps or discards the change, and repeats. You wake up in the morning to a log of 100 experiments and hopefully a measurably better model. It's basically automated grad student research, except the grad student never sleeps and never gets bored. The numbers on this thing are honestly kind of absurd. 70,000 GitHub stars in 5 weeks. Over 10,000 forks. 180 open issues, which tells you people are actually using it and hitting edges. And the whole codebase is basically 3 files. That's it. This went from 0 to 70,000 stars faster than almost anything I've tracked this year. And it's not because of hype. It's because the idea is so obviously right that everyone who sees it immediately wants to try it. Let me show you what's actually in the repo. Okay, so right at the top of the README, you've got this progress chart, and it's honestly the perfect visual for what this project does. Each line is a different experiment run, and you can see them fanning out over time as the agent tries different things. Some go up, meaning they got worse. Some go down, meaning they improved. The ones that survived get carried forward. Below the chart, there's this incredible opening quote from Karpathy, and I have to read part of it because it's so good. Quote, "One day, frontier AI research used to be done by meat computers in between eating, sleeping, having other fun, and synchronizing once in a while using sound wave interconnect in the ritual of group meeting. That era is long gone." End quote. He's half joking, but also clearly not. Then you get into the actual explanation of how it works. 3 files. Prepare.py handles data download and tokenization. That's fixed. The agent can't touch it. Train.py is the single file the agent modifies. It's got the full GPT model, the optimizer, the training loop, everything is fair game. And program.md is the instructions file, the markdown document that tells the AI agent what to do. That's the whole project. Scroll down a bit further, and you've got the quick start, which is literally 4 commands. Install UV, sync dependencies, run prepare, run train. And then the section on running the agent is just, quote, "Spin up your Claude or Codex in this repo, and prompt it with have a look at program.md. That's it. No framework, no config files, no orchestration layer. So why does this matter beyond being a cool weekend project? The honest answer is that Karpathy identified something that most ML researchers already know, but nobody had packaged this cleanly. The bottleneck in deep learning research isn't compute anymore, it's human attention. A researcher has maybe 4 or 5 good ideas per day, and each experiment takes long enough that you can only test a handful before you run out of working hours. Autoresearch flips that completely. The agent generates ideas continuously, tests them in fixed 5-minute windows, and logs everything. You go from 5 experiments a day to 100 experiments overnight. And the experiment quality isn't random, because modern coding agents are actually decent at reading research papers, understanding code structure, and proposing reasonable architectural modifications. Let me give you the actual spec sheet. Train.py is 630 lines, and that's the entire model, optimizer, and training loop in a single file. The training budget is fixed at exactly 300 seconds of wall clock time, so every experiment is directly comparable regardless of what the agent changed. It uses the muon optimizer paired with AtomW, which is a very specific and modern choice that gets you better convergence in short time windows. And the whole thing runs on a single GPU, tested on an H100, but designed to work on anything with enough memory. The design choices in this repo are where it gets really interesting. First, there's only one file the agent can modify. Train.py. Prepare.py is locked. The evaluation function is locked. The data is locked. This is a hard constraint, and it's brilliant because it means the agent can't cheat by inflating metrics or changing the eval. Every improvement has to be real. Second, the metric is val_BPB, which stands for validation bits per byte. It's vocabulary size independent, so if the agent decides to change the tokenizer size from 8,000 to 4,000, the results are still directly comparable. Third, there's a simplicity criterion baked right into the program.md. A tiny improvement that adds 20 lines of ugly code is explicitly not worth keeping. An improvement of 0, but with simpler code? Keep it. This is Karpathy encoding his own research taste directly into the agent's instructions. And fourth, the agent is told to never stop. The program.md literally says, quote, Do not pause to ask the human if you should continue. The human might be asleep. The loop runs until the human interrupts you, period. Now let me walk you through how the experiment loop actually works in practice, because the program.md reads like a very well-designed research protocol. The agent starts by creating a fresh Git branch, reading all 3 source files for context, and running the baseline with 0 modifications. That first run establishes the number to beat. Then it enters an infinite loop. It modifies train.py with an experimental idea, commits the change, runs the training for 5 minutes, and checks the result. If val bpb went down, the change stays and the branch advances. If it went up or stayed the same, the agent does a git reset back to the previous commit and tries something different. Everything gets logged to a TSV file with the commit hash, the metric, peak memory, status, and a description. So when you wake up in the morning, you've got this clean spreadsheet of every experiment, what was tried, what worked, and what didn't. It's basically a research notebook written by a machine. Under the hood, the model itself is a standard GPT with some very modern touches. It uses Flash Attention 3, the latest version, with automatic fallback to a community kernel if you're not on Hopper hardware. The attention pattern alternates between sliding window and full context using a configurable pattern string, which is a trick from the Mistral architecture. There's rotary position embeddings, RMS norm, and a value embedding system called resformer, where value residuals from earlier layers get mixed back in with an input-dependent gate. The optimizer setup is interesting too. It splits parameters into 4 groups with different learning rates. Token embeddings get a high learning rate through Atom. The unembedding head gets a low one. Matrix parameters use the muon optimizer with cautious weight decay, and per-layer scalars get their own Atom group. It's a very carefully tuned setup that wouldn't look out of place in a production training run at a large lab. Getting it running is 4 commands if you have a GPU. Install UV, which is the fast Python package manager from Astral, sync the dependencies, run prepare.py to download training data, and build the tokenizer, and then run train.py to verify everything works. After that, you just open your coding agent in the repo and tell it to read program.md. That's the entire setup. No Docker, no config files, no environment variables. If you don't have an NVIDIA GPU, there are community forks for macOS with MLX, Windows with RTX cards, and AMD with ROCm. The forks handle all the platform-specific kernel stuff, so you don't have to. So who should actually clone this and start running experiments? There are basically 4 groups. If you're an ML researcher at any level, from grad student to staff, this is the most efficient way to test a large number of architectural hypotheses on a single GPU overnight. You set up the experiment, encode your research taste into program.md, and let it run. If you're a hobbyist who has a gaming GPU sitting around and has always wanted to understand how LLM training actually works, this is maybe the best educational project in the entire open-source AI space right now, because the codebase is small enough to fully read and understand in an afternoon. If you're building AI coding tools, autoresearch is essentially a benchmark for how well your agent handles long autonomous loops with real feedback signals, which is a very different test than writing a web app. And if you're just someone who follows ML research and wants to understand where the field is going, this repo is a preview. Karpathy is basically saying the future of ML research looks like humans writing instructions in Markdown and machines running the experiments. Okay, let's be real about what's not great here. You need an NVIDIA GPU to run the original repo, and the community forks for other platforms are still catching up in quality. The 5-minute time budget means results aren't comparable across different hardware, so your H100 experiments and someone else's RTX 4090 experiments exist in different universes. There's no built-in way to combine good ideas from separate runs, so the agent can't do the kind of cross-pollination that a human research team would naturally do over coffee. And program.md is honestly pretty bare bones right now. It's clearly version 0 of what should eventually become a much richer research instruction language. But for everything that's wrong with it, this project hit something real. 70,000 stars in 5 weeks doesn't happen by accident. Karpathy took an idea that every ML researcher has had, which is I wish I could just run experiments while I sleep, and turn it into 3 files and 4 commands. It's MIT licensed, the code is clean enough to fully understand in a single sitting, and the community is already building forks for every platform. If you train models in 2026 and you haven't at least read through program.md, you're missing how the next generation of ML research is going to work. Links are in the description. Thanks for watching. I'll catch you tomorrow.